Good afternoon, everyone. Thanks for being here today. I was just looking at the clock and going, is it evening or late afternoon? So I guess it's still late afternoon. So I'm Swapnaya Sarapu, and this is Shashidhar Joshi. We are both from Microsoft, from Azure, and we wanted to share some of our thoughts around what the new cloud workloads are and their implications on the media futures, especially as we think about building up new media technologies for the next decade. So, just to frame the discussion, what we want to really talk about today are some of the trends that we are seeing from a growth in cloud storage services, especially as they pertain to the storage media technologies. SSDs and hard drives have been the foundation on which the Azure storage technologies are built and services are delivered to our customers, and they are growing. They have been growing at an extraordinary scale over the last decade, and we expect to continue to see this trend. However, as we think of this growth, the technologies that we've used in the past may or may not be enough as we look at the workloads of the future, because our customer requirements are morphing and the promises we make to our customers actually are also changing with that. So what we wanted to share with you today are some of the aspects of storage technologies and how they're getting used in the data center in our cloud services today. And what do we need to do to continue to grow our existing applications where storage is being used? And what are some of the new opportunities for storage media? Like, where else can we apply them, and what do we need from the storage media to be able to do that? So with that in mind, just to frame where we are at today, I think Shashi talked about this in the last session in terms of the growth of storage. This is a well-known data point from IDC that talks about by 2025, storage is expected to be about 175 zettabytes. Now, this growth is not uniform, as in the applications that have been driving the growth of storage in the last, say, 5 years are not the only applications that are driving growth as we move to the right. So our customer promises are also morphing to drive this growth in storage. Our customers are demanding more from a security perspective. The availability and durability requirements are going up, especially as the born in the cloud applications are growing and enterprise applications are migrating to the cloud. It drives different requirements. For example, another example of this is the performance requirements. Our customers are actually requiring more performance. So they are raising the bar on performance even in current segments. The scale at which our customers are deploying data is increasing. Now we see more and more customers that are driving exabyte scale, multi-exabyte scale of data into the cloud. And what that means is, of course, the scale itself is going up from our customers' perspective on how they want to deploy and how quickly they want to deploy these multi-exabytes of data. But their requirements or expectations around cost and capacity on a footprint basis is also expanding. And as the data estates are growing in the clouds, there is certainly a need for managing these large data estates of our customers and finding low-cost solutions for storing them over a period of time. So from an Azure storage perspective, the portfolio of our services that we deliver generally fall in three groups. There's block storage, object storage, and file storage. And if you think of block storage, it's like disk storage, right? But it's also SAN storage. Object, when we talk about blobs, that's our term for objects, but there's also large data estates that we store, which are called data lake storage. And then files, which we do native Azure files, as well as we do Azure NetApp files, which is in conjunction with NetApp, which provides file storage. But across all of these services, right, we actually deploy storage in broadly two buckets. What we call standard storage, and Shashi and I may use this term quite a bit, is generally storage that we use HDDs to deliver storage with. So the platforms use hard drives. And what we call premium storage is where we use flash or SSD for the media technologies. However, both of these, both standard storage offerings and premium storage offerings span block, object, file. It basically spans all the different types of storage services. Now, which basically means that the applications that are deployed across our services scale themselves right across the storage services and also in their performance requirements and or capacity or scale requirements. So 5 broad categories of applications that we see on Azure from a storage perspective are, of course, BCDR and archiving, which is basically for, it could be anywhere between active archive to long-term preservation markets, born in the cloud or cloud-native applications, enterprise applications, so databases, transaction processing that typically were, the bread and butter of enterprise applications do find usage on the cloud or want to be run on the cloud. Analytics, HPC, and of course, machine learning and AI, which everybody, I think, has seen a big surge on in the recent year, I guess I should say. So when we think of these applications and think about what kind of workload properties they drive, we could think of them in terms of throughput and IOP performance, latency, write intensity, or how much of these applications writing to the underlying storage, and of course cost. So these are the 5 metrics we look at. And as we think of these applications, this spider chart, radar chart, kind of gives you a relative requirement of applications versus some of these key metrics. So as an example, enterprise applications, which is the dark blue, tend to drive more performance versus born in the cloud native applications, or even, of course, the backup and recovery and archival applications. And at the very opposite side of it, AI/ML applications, which do drive high throughput and requirements, are less cost sensitive versus the archival as well as cloud native applications. However, the absolute requirements really drives whether they land up sitting on standard storage, where hard drives get used, or on premium storage, where flash or SSDs get used. So with that in mind, what we wanted to do is share with you, if we looked at the usage of both the media technologies and the data center, what some of the key or few metrics look like relative to each other, and give you a sense of how we look at these. So first, what we have over here are IOP charts. So read versus write, IOPS mix. Blue is reads on both the charts. Green is writes on both the charts. The left side is how the SSD media is getting written to versus read from, and the right side is HDD media, where it's getting written to versus read from. And in general, I think the key takeaway that we'd like you to take from this chart is that both SSDs and HDDs see about 60% or so workload actually of writes. When it's all said and done, customer writes, any internal replications that we do, any other internal housekeeping that we do, that ultimately gets written on the storage class. So it's not that the standard storage is getting any less writes, but with respect to reads, but in absolute terms, the performance is lesser on standard storage required versus the premium storage. So you're writing just as much, relatively speaking, versus reads on hard drives and SSDs. However, the rate at which we are writing is different between the two media, which kind of is obvious, since it's HDD versus flash. So the takeaway is, as we think of using media in different classes of our services, it is the relative read to write ratio that about remains the same, but you raise or lower the bar based on what kind of an offering that we're providing to our customers. The next chart, similar, but this is in terms of throughput, so megabytes per second, same color scheme. The blues are reads, the greens are writes. The left side is SSD media, and the right side is HDD media. And a couple of things. The relative mix of reads in terms of throughput is more when compared to what you saw on the previous chart. And I might have mixed the numbers up here, right, Shashi? Reads are green, writes are blue, just to be clear, on the right side. So here, it's a little, what the bigger takeaway is that it's almost close to 50-50 as opposed to a 60-40 mix, so in terms of a throughput. However, the key message remains the same, which is you're not, as we are moving from one type of media class to the next, we're not really saying you're writing any less, relatively speaking. We're actually writing less in absolute terms, but the mix is about the same from a storage media usage perspective. And the third one is latency.
You've been asked to take questions at the end of the session.
At the very end.
What's the x-axis on the previous slide?
What's the x-axis?
Okay, I should, it's a good point, yep. So the x-axis is just all the deployments that we have across platforms. So different media in different regions of the world, across different workloads. So it is all aggregated, so you can kind of get the sense for what it looks like in its totality.
So more vertical lines on the SSD side means more variety on the SSDs?
I think more vertical lines means it's just a little bit more granular in how we took the cut of the data from our fleet. So think of it as we are deploying SSDs versus HDDs, we just took a cut of the data, which is a little bit more granular. Like, so instead of, say, at a cluster level, we took it at a rack level, or if it's at a rack versus device level. That's all. It's just it's a complete sample, but it's telling you the same story, right, at the same level.
Trying to cover as broad a spectrum as we possibly can across the fleets that we have.
Yeah. So so this chart is around read latencies, and in general, we care more about read latencies than write latencies. And the bigger, I think, message over here is, of course, no surprises that there's an order of magnitude latency delta between green, which is the SSD, and blue, which is the HDD line. But in general, I think the bigger takeaways is that in terms of the latency on SSDs, and these are average latencies, but broadly holds good for some of our P9s, is that we are seeing the latencies on SSD being consistent as we progress capacity. So as we are going from, 8 terabytes to 16 terabytes and beyond, we can maintain our SSD latency as we are scaling throughput. However, on the hard drives, on the HDD, we are seeing a degradation in latency as we are moving to the higher capacities, and this is a problem. So that's something we need to kind of make sure that we can address as we move forward. On SSDs, that's not as much of a problem at this point in time. So what does this mean kind of at the high level? We wanted to give you a sense for how relatively between premium storage and standard storage some of these key metrics look. But if we get into the flash or the SSD implications, there's actually two sides to this coin. Like, what do we need from flash-based devices or SSDs going forward in order to maintain our services for our incumbent applications? So in our premium storage applications, that's the left side. And the right side is, if we could build a different class of SSDs, what would it look like in order to grow flash into more towards our standard storage offerings or where HDDs are generally used today? So those are kind of the two sides of it. The left side, so let me start over there. So to grow within our incumbent applications, there's One is around power and power efficiency. So we do need to maintain better power efficiency, so reduce our watts on a per terabyte basis. That's number one. Second is reducing our idle power. And the third is around providing more in-field power and performance tuning. And I know there was a discussion earlier today around thermal management and power management. I think the one piece that we do need to keep an eye on this is, as we are doing in-field power performance tuning, we can't walk away from the predictability of our services as they make promises on the latency basis. So it is a problem we need to solve. There are ideas being thrown out here, but we have some more work to do on this front. The second is throughput, or megabytes per second per terabyte scaling. Now, we don't see a problem with IOPS per terabyte scaling, because there's just too many IOPS in an SSD today, even for our premium storage offerings. However, we do need to solve for megabytes per second per terabyte scaling of SSDs as we grow their density. And this is while we maintain that latency profiles that I was talking about on the previous chart. So that's the second piece. The third, and this is something that we are seeing more and more a need for as we scale our densities, is around workload shaping, data placement, right? That now we, of course, have been on the ZNS journey. So that's one of the examples, but obviously there are others as the applications find fit. And this is all about how can we reduce the overall system write amplification. And it's very important for us. There's just no doubt about it. So technologies around this matter for us. And the third is around petabytes written per terabyte, or endurance. And the bigger message here is, as we scale density in our incumbent applications, we do need to maintain a minimum endurance, right, which is petabytes written per terabyte basis. And this is why workload shaping, reducing write amplification, becomes very useful as we get to look at new media technologies. Now, the flip side of it is, and it's a question that we always get asked, is, hey, can you use SSDs instead of hard drives? And we always say, no, we can't. Hard drives have a very special place. They solve a very, very important problem for us. But a question that we always get asked is, what would it take? So this is an attempt for us to give some guidance to the ecosystem partners in the industry on what we think it would take for SSDs or flash to be used where we generally use hard drives today. So one is around density scaling. We think that for hard drives to be used in our SSDs to be used in our standard storage offerings, at any given generational point of time, we need to be somewhere between 5 to 8x in HDD density for an SSD. So if an HDD is 10, we need to be at the SSD at somewhere between 50 and 80 terabytes, right? So that's kind of our math on how it works out. From an acquisition cost perspective, we don't have to be at cost parity on a per terabyte basis, but we need to be between 2 to 3x on a per terabyte basis on cost from HDDs. On a throughput per terabyte, and I talked about this on the left side too. So we think of it from a throughput per terabyte because that will be the limiting metric. It should be around 2 to 4x of HDDs for us to be able to use this. And the very last one is, yes, we can trade off endurance, and that really depends on how much writes we are doing. So the trade-off of endurance is kind of tracking to the trade-off that we make on write performance, right? So that's kind of the way to think about it from an endurance perspective. And those are kind of the 4 metrics or knobs that that the industry can use to tune for us to fall into this new opportunities for flash.
Can you clarify what is throughput? Is megabytes per second for sequential, or it could be random and you're looking at megabytes?
It's a good question. So it is mixed read-write, random workloads, and our block sizes can actually move quite a bit. On a write basis, we have control over our block sizes a little more than we have on the read basis, but it is mixed random. So that's a metric to look at.
And you care about throughput on the mixed drive.
Yeah. While maintaining our latency attributes. So just to kind of leave you with the key thoughts over here, right? We have very clear segmentation. Now this is a chart of x-axis is acquisition cost or dollars per terabyte. Y-axis is performance per terabyte. And the top left is where SSDs sit today, and that fits well within our service offerings. The bottom right is where hard drives sit today, and that fits well within our service offerings for standard storage. And the big takeaway is, in terms of price performance, right, flash or SSDs don't have to sit right on top of HDDs for it to make sense, right? So there is this landing zone that we believe for a new class of SSDs that can allow us to use it in standard storage. So that gets us from how we use flash going forward, and Shashi is going to take us through the HDD side of things.
One quick question.
Sure.
Retention, you don't care about retention? Like SSD vendors typically provide retention 3 months for replacement. Do you have a retention spec?
Yes, we do have a retention spec. The OCP spec actually talks about it. I think in general, we don't need 3-6 months of retention. I believe the spec talks about it being at 1 month. That's plenty for us. If you think about it, if we take our data center down and not use the devices for a month, we have bigger problems, right? We need them up and running all the time. Shashi?
Yep. Thank you. All right, so we'll try to cover the same things on the HDD side and the storage infrastructure that we have supported by the HDD. The value for HDD has been amazing up until now, right? So the metrics that we have looked at, the critical metrics are obviously cost and capacity, performance per terabyte, workload rating, and power efficiency. So up until now, the capacities have grown at a good, healthy rate, while the costs have continued to come down at a good, healthy rate as well. The performance has been declining, but it has been acceptable, assuming that the software improvements have tried to master it so far. The workload rating has been stagnant, and we'll see what we really mean by that. And from a power perspective, the last time HDDs had a significant reduction in power was when the helium drive was introduced. Now, when we project all of these things, these same metrics moving forward, the suppliers have robust roadmaps on HAMR and SMR technology, so we do hope that those come to fruition, because they will certainly continue to improve the capacity, which everybody wants and likes. Performance per terabyte, unfortunately, is going to continue to decline, and that is untenable. So there has to be something that needs to be done in terms of HDD performance. The workload rating, again, is not going to be sufficient moving forward with these high capacity drives hitting the market. And then from a power efficiency, again, there's a need to improve, whether it's another technology, something that is similar to helium or what have you, or better power management features that allow us to operate the drives at a much lower power than we do right now. So let's dig into the performance aspect now. So on the left-hand side, the chart that you see is it's showing two curves, and those two curves are representing two separate HDD performances. So the industry today has a single actuator drive, which has been the predominant drive. And then very recently, a few years back, there was a dual actuator HDD that was introduced in the market, which doubles the performance. So the two lines that you see are those two curves, I would say. The x-axis is obviously the capacity. So we've taken it from 10 all the way to 100, right? That's the spectrum of capacities that we are looking at. Today, the industry is somewhere between 20 and 30, right? That is where we stand today. Now, if you look at that performance, we are assuming 10 as the baseline. And the reason to assume 10 as the baseline is simply because at 10 TB, most all of the industry was on helium drives, so they were the low power drives. The drive was good and sufficient in terms of its performance, power, all aspects, right? So we are taking that as a baseline. Now realize that any entity out there who's deploying HDDs can have their own baselines, right? So they can either take 20 or 30 as their baseline. So that's up to, however they are deploying their services. So if you look at the left-hand side chart, when we went from 10 to 20, it was a 100% decline in the performance. And then from there on, every subsequent bar is showing you relative decline in the performance compared to the previous capacity point. So you can see the y-axis, we don't have numbers, obviously, for obvious reasons, but the performance is substantially lower than where you see your baseline to be, which is 10. Now, if you look at the right-hand side, that is showing a cumulative decline, right? So this is assuming 10 is your baseline, and then from every generation of drive thereon, 20, 30, 40, 100, how much decline in performance are you seeing based on your baseline? It's a huge, huge, huge decline. So where we are today, where rather the industry is today, between 20 and 30, we have been able to mask that huge performance delta by using software improvements or other techniques like caching, etc. Right? So there are techniques in the industry that have been employed to compensate for that decline. However, moving forward, those same software techniques may not be sufficient enough to continue the application of these HDDs into our existing storage infrastructure. Now, dual actuator HDDs certainly help, as you can see, but they only help over a certain finite amount of capacity, right? If you look at the 100 TB drive or even the 50, 60 TB drive, it's a substantial reduction in performance compared to your baseline. So all in all, what this is saying is the industry needs to identify options to go improve IOPS per terabyte, and more importantly, megabytes per second per terabyte metric for the HDDs. Right? Because unless that happens, we won't be able to use the HDDs the same way that we have been using it up until now.
Just a quick question, is there a timeline on your up to 100 terabyte?
That is dependent on HDD suppliers as to how quickly they can crank out those capacities. But
Just comparing to SSDs then, you want a half petabyte SSD during that time frame?
could be.
Let's do it.
So then another aspect of the same performance on HDDs is utilization. So think about a 20 TB HDD and think about a 10 TB HDD. A 20 TB HDD by itself as an entity will house more data, will service more number of customers, and as a result will be busier. So the higher the capacity, the busier the drive, the more it gets utilized. Now we can approach to 100%, but going beyond 100% and even approaching close to 100% is not good, right? And once you go past 100%, assuming that you can sustain 100% utilization on an HDD, then you start stranding capacity, which means you can deploy a 40 TB drive, but you can only use 30 out of those 40 TBs. So you're leaving 10 terabytes worth of dollars on the table. You cannot use that drive at all for anything. So again, to solve that problem, we really need better performance so that the HDD with more data, more customers can service this appropriately, and then better workload rating. Yes?
Quick question. I don't see anything in the presentation or in the slides on HDDs about accounting for hard drive failures, which obviously happen more often on HDD than SSD.
Yes, so we haven't accounted for reliability in this deck. It has been predominantly based on performance, but your point is well taken. Reliability is a big concern, and to your point, the more the drive gets utilized, the higher the susceptibility of the reliability.
Well, I mean, if the drive fails, it affects performance because you're now operating and you've got more IOs because of
Correct.
that. So that's not accounted for.
That's not.
Do you count that reliability to your cost, like the TCO? For example, the SSD has better endurance than HDD.
So we can take those questions at the end if you don't mind. We'll certainly take all the questions. I think we were done with this slide. So what does HDDs look like going forward? Similar to what Swapna covered on the SSD part, for HDDs to grow within the incumbent applications, i.e. what they're currently servicing, we need the capacity and cost to continue to improve. Again, if HAMR and SMR roadmaps come to fruition, we see good line of sight towards that being enabled. Performance and workload rating, again, as we saw on the previous chart, it needs significant improvement on both aspects of it. Quality of service, this has to do with latency management. Again, the bigger the drive, the more it starts suffering based on latency. Remember the chart that Swapna talked about on the latency? You could see the trend for HDDs as a function of capacities, the latency is going up. So that needs to be able to managed. This blast radius problem, if you have 20 heads and you have a 100 terabyte drive, each head has a lot of capacity on it. If you lose that one head, you lose the whole drive. So again, the industry is trying to bring up features like depop, etc., which is a good thing to do. But there's, again, room for improvement over there, whether we can improve that implementation. And then power efficiency. Of course, again, as data center needs low power footprint, it's good for the data center to have low power footprint. And as a result of that, any power efficiencies on HDDs will go a long way. Especially with better performance, there's normally a trade-off with power. Now, if we think about newer opportunities, similar to how SSDs have new opportunities, there is expansion of the HDD archive tier. So again, from a TCO perspective, because that's the single most metric when we think about archive and HDDs together, we need a significant amount of improvement to make the TCO good enough for HDDs to play into that. Other things like performance, latency, and workload rating are negotiable things. So those are things on the table that can be traded off to try and compensate for the first bar, which is the TCO. So if you look at that landing zone, so what you see on this graph is, again, prices on the x-axis, there's performance per terabyte on the y-axis. The two dotted lines that you see, the orange one is for the low performance, which is the single actuator drive. The blue ones is for the high performance, which is the dual actuator drive. Standard storage, as we call it today over here, the green bubble is the space that HDDs will continue to meet today, and then archive storage is where they want to be in the future. So the dots where you don't see any bubbles shaded, that's kind of a no man's land, right? Because that is where the HDD is neither good for an archive application, nor is it good enough to go sustain the existing applications. But that's where the trend looks like going, if we just assume the performance to be the same and the capacities to keep growing. So now if we put this all together, so the things that Swapna covered on the SSD part, the things that I covered on the HDD part, we are putting it all on the same scale. Again, x-axis is dollar per terabyte, y-axis is performance. So SSDs, again, there's the SSD opportunity bubble that you see in the standard storage. The current HDDs are shown in those transparent oval shapes. Where we really want HDDs to go is on the green oval. We want the cost to improve as a function of better capacity, as it has been doing in the past, but we also need HDDs to maintain a certain threshold performance on a megabytes per second per terabyte and IOPS basis. And that's the area where we would like the industry to go invest from a standard storage perspective. The red bubble is, again, it's a no landing zone because it doesn't help anything. And then the blue part is where HDDs have an opportunity to go play in the archive market, which is really cheap and deep. Cold data, archive data, and other performance metrics are for trade-offs and are negotiable. I think we are at the last slide and I can take questions. Nope, there you go. Yes, so
Going back to that one, the blue bubble, is that challenging tape or is that a different thing, a different animal?
we look at it as if HDDs want to go make a space for themselves in the archive, that's where we would say. Now, HDD latency is always going to be better than tape, right? So it really is not a displacement equation there.
But I'm talking about application. Is this an application that displaces?
Yeah, so Active Archive is an application which is latency sensitive, but it is archive data. So that is one such example of an application that fits the bill there. Yes, over here.
My question is, when you talk about the cost at the TCO, do you consider the endurance? So for example, like the data rate can also be part of that. Like for HDD, it has worse data rate, and then if you look at it overall, like this, do you consider the overall situation? Calculate your TCO?
Yeah, so we do take into account all of those things. We have extensive in-fleet data to go analyze, and we know exactly what is our failure rate, how many drives can we recover versus not recover, and what impact it has on our TCO. So yes, that is part of the equation. Yeah?
Swap that on, you mentioned as part of power efficiency idle. Part of me has been trained that data center drives never go idle, so it doesn't matter. Is there an idle residency that you guys think or see are going to be in here that you're trying to save power for, or are you really talking about more kind of the floor power while it's busy? Is there a difference between the two?
Okay. So your question is, when we think about the idle power that we talked about, is it more about setting the floor or is it true idle, right? I think there's two aspects to it. So it is, of course, the floor, because that drives the watt per terabyte, right? But also, as we kind of look to the future, one of the big initiatives that we have made, and we'll talk about this tomorrow, is around sustainability. And we do need to drive to a more greener data center, which actually means that we do need to be efficient when the device is sitting idle. Now,
So there are an existence proof of an idle drive in Azure.
you know, it's a good question. Yes, yes. I think we're starting to pay more attention to those pockets, I think is the way to put it.
So if you look at those two slides where you have the future opportunities for SSD, and if you kind of just put side by side, you have multiple factors. So is there a particular ranking you would give, say, hey, instead of all fives, I would just take top two, right? Because not all five factors would be come to realize.
So on the HDD part, so sorry, I should repeat the question. So his question was that if we compare the going forward path for SSDs and HDDs, do all those things need to come to fruition, or can one or two of those not come to fruition and we would be okay with it? So I'll address the HDD part first. So again, performance, latency, workload, everything is up for negotiation or trade-off, but cost has to come down, right? That's the single most metric for HDDs at least. So
I think on the SSD side, where did it go? There we go. Yeah, on the SSD side, I would say the top two are kind of the drivers and the bottom two are the trade-offs, right? So these are the gives, these are the gets. There's room here, right? If you drove this much more aggressively, perhaps, you know, if you have 8 here, you're down to 2. If you have 5 here, it's up to 3. Stretch and pull. And as much as you pull this is how much trade-offs you can make over here, right? That's the way to think about it. But so I think the best way we can answer this is one way we have kind of proposed to solve it, but we're always open to ideas. If there are certain metrics that will give more, right, I think we should have a discussion around it.
Could you explain the track to writes a little bit more?
Yes. And we were thinking about that when we put this together. So the question is, could you please explain the track to writes? What does that mean? Let me see if I can explain it. So a few charts back, we talked about how whether it's an HDD or an SSD, when you look at read and write mix, the relative read to write mix is about the same as we use in the fleet. So 50-50, let's call it, right, in this case, whether you're using an SSD or an HDD. But what's different is the total rate of write, megabytes per second, that each of these two media is taking, right? So if an SSD can write 10 megabytes per second, HDD can write 1 megabyte per second, 2 megabyte, whatever that is, right? There's a ratio of it. So the point we're trying to make over here is we're gonna trade off the SSD to drive capacity up and to drop the throughput per terabyte. You can drop the endurance on a total petabytes written per terabyte at the same rate. That's what it basically means. So it's not a firm, like a lot of questions that we get are around, hey, can we do 0.1 drive writes per day, right? Can we do 0.05 drive writes per day? The metric is tied to how much write rate the device will take.
So are you making an assumption the endurance is, the writes is more important to the endurance, the rates is not?
So the question is, are you making an assumption that writes are more important to endurance versus read?
Factoring endurance?
Yeah, so in general, we track where in terms of how many writes we're doing. Of course, the more you write to it, the media can actually show itself to have errors in different ways, and I think there's more experts over here who can talk to it. So we're not saying that writes are more important. We're just saying you can trade off endurance as you're trading off performance. If that makes sense.
Yeah, in other words, writes is affecting the endurance more than the read.
Yes.
That's the impression.
Yeah.
Go ahead.
So I had a question about the read-write balance. You have it at 60-40 for writes to reads, and you have it at 50-50 writes to reads. I've very rarely seen that kind of workload. It's usually 80-20 reads to writes. Is that because these are more ephemeral instances in the cloud, or
No.
why are they getting more writes?
I think what you're asking is, hey, why is the relative ratio of writes high? This is net. I think the way to think about it is this net how we're writing to the media, which is a function of customer as well as non-customer. So we, for example, we replicate data. So you could read once, but as we replicate or we build in redundancy, we actually are doing more writes, right, relative to how much a customer is writing. So that will throw off the ratios net to the media versus what you would expect an application to see.
Okay, I think I see. So you're saying that your underlying software that builds in the resiliency is causing some write-up?
Yes, correct. Yes, it will, yes. Hang one tight, Dan. There's a question here.
So as the density goes up for SSD, the blast radius obviously goes up.
Yes.
So does that require you to like upgrade all your infrastructure? Networking has to be faster, so your rebalance, rebuild, etc. happens faster. What's the real calculus there in terms of like blast radius, and can you say something about that?
So repeating the question, I mean, your question is, as you're driving more density, how are you managing blast radius, right? So I think the way we would answer that is, yes, there is a calculus to what the blast radius implications are, which do show up in terms of speed requirements, networking requirements, and also non-media, right, like other compute requirements. So we try to keep them balanced every generation, and it is a map that we work on. One thing we didn't explicitly call out here is, of course, we need to make sure that we are managing to the blast radius. And actually, I think things like workload shaping and ZNS actually help with that, right? Because it can actually help reduce your blast radius impacts. Shashi, if you have
On the HDD side, yeah, there's depop and other features like I mentioned that are useful, and they will potentially be even more useful with bigger drives in the future, especially because if just one head goes bad, the whole drive shouldn't be treated as bad. Right?
Thank you.
Go ahead, Dan.
I enjoyed the presentation, so when you present it again, because this is still going to be interesting in the future, I would be really curious to see deallocates added into the charts of the reads and writes as well. It's just another thing to try and wrap my head around.
Fair enough. Yeah, we'll get that
Why
some
would
thought.
you delete data?
Good.
Yes, please.
Does this, would this chart be different for TLC versus QLC? Any chance?
No. We are media agnostic, right? What can fit is what we take.
You want to put your last slide close?
Yeah, sure.
Where would you put TLC and QLC?
So we use QLC today in our mainstream devices, so we're already on that path.
So do we consider the QLC as a mainstream?
Yes, absolutely. I forgot to repeat his question. The question was, how do you look at TLC versus QLC in this continuum? Please.
Yeah, I also have a question about the slide. You mentioned it's important for HDD when they raise the capacity, it's important to keep the performance. What do you think are the options for HDD to keep the performance? You know, they're already doing dual actuators. Do you think they go to call actuator? Or is there another HDD vendor to add, proportional, NAND flash on it? Do you think those two options, that's what I know, would that keep going?
Yeah, so to repeat your question, you're asking on the HDD side, we are asking for better performance. What options do the suppliers have to go improve that? Whether it's, we already have dual, do you really are asking for a quad? That was your question, right?
Right, or add more HDD.
Or add more NAND and make it yeah. No, so great question. So there are things that HDD suppliers can do to go improve performance. It can be, there may be a choice to do between improving IOPS versus improving bandwidth. It's easier for HDDs to go improve bandwidth, difficult for them to go improve IOPS, right? And that has to do with the size. HDDs work phenomenally when you do sequentials. They don't do as well when you randomize the whole workload. So even beyond dual, there are options that HDD suppliers have to go improve the performance. Yep.
So the question about this graph, because there's a nice log decline left to right, bottom, top to bottom, except for the HDD requirement, which is going up and to the right. Why wouldn't I just want the one that's furthest up and to the right? Right? So this must show a progression over time, but nothing else is showing progression over time.
Yeah. So I think, the intent there is to try and move as away from, let's say, the SSD opportunity that is shown up over there in the bubble, right? So the HDDs have to distance themselves apart from the SSD that views the new opportunity as wanting to, let's say, displace it. And hence, the further out that they can go, the better off it is. And this metric is, you can think about a smaller HDD with a cheaper price, but that does much better on the megabytes per second per terabyte factor.
So you had millisecond as the requirement for latency.
Correct. So that's correct.
Right, but that's not possible.
Millisecond is possible for HDDs.
Milliseconds, I think.
Yeah. Milliseconds. So yeah, it's not 1 millisecond. Yeah. Sorry, it's milliseconds.
Milliseconds, okay.
Yeah. Yeah, no, I was not asking for just 1 millisecond. No.
What about, is there going to be a storyline different for the ephemeral storage side of this? Because I'm assuming this is all the persistent, disaggregated storage. Is there going to be a different storyline for the ephemeral VM storage?
So your question is, hey, is this informed by ephemeral storage or is it all for persistent storage? This is all focused on persistent storage. So the dynamics around ephemeral storage can be different. 1, 2, 3.
Go ahead.
Quick question, are you really looking, tiering between premium storage and standard storage where you have the SSD opportunity?
So could you repeat the question?
So today we can do the tiering, right, between the storage, whether it is a standard or it's a premium storage. Are you thinking of having a tiering within the SSDs?
Okay, so your question is, in order to hit the premium storage opportunity versus standard storage opportunities, are they different tiers of SSDs? And the answer is, we believe that's how it would be because there is a home for performant SSD storage for our premium offerings, but if we want to use SSDs where in the region of standard storage, it's going to take something different. So yes. Thank you. Gentleman.
I think for both, for the random read writes, both HDD and SSD are struggling. Is there opportunity at the system level trying to make it more sequential? Or if not, what is the challenge and cost at the system level?
Yes, so your question was random is struggling for both SSDs and HDDs. Is there a means at the system level to improve the performance instead of at device level?
To make it more, line up the data.
Yes, so we optimize at a system level, right? We always do that. So that is already baked into these calculations when we are thinking about it. Now, a device will further help us go even improve upon that factor. But if you remember the chart that I showed on the HDD right over here, the reason that we can, or the industry I should say, this is a common statement across the board, that we can use a 20 TB drive as well as we did a 10 TB drive is because there were several software improvements or system level improvements that were made in order to go compensate for the decline that happened on the device level. Does that answer your question?
Yeah, actually I want to say what's the hot floor there, at system level. Yeah, our system level already exhausted the effort. There's still like 40, 60, 30, 70, random versus sequential. Sorry, HDD SSD guys just have to deal with. I'm interested in that ratio. Say like a Microsoft system level, all kinds of applications, platforms. Where is that hard threshold?
Yeah, so I don't think we can comment on where our where do we see that boundary or how much have we optimized versus not. I don't think we can say that or state that, but suffice to say that is our effort is always to go solve at the system level, right? There was one more gentleman there on the right hand side who had his hand up. Maybe not. All right, go ahead.
Yeah, so my question is, mostly on the flexibility perspective, more on the writing, most of piggybacking on that question, writing optimized to the SSD logical block size, right? Native media block size and optimizing writes for that and reducing therefore write amplification as well as performance. Is that already accounted for when you are looking at next opportunity?
Okay, so your question is on the SSDs, is the optimization around writes to reduce the write amp completely accounted for in this case? If we went back to the chart where we are talking about this, I do believe some of the scaling that we are already driving in our fleet for incumbent applications is accounting for those write improvements, and we would expect that to continue if you wanted to hop over to the right side of the chart.
We were just notified that we are out of time, but we can take questions offline once we're done with.
We're formally out of time, but happy to answer any questions that pop up.
Thank you.